Okay, let's look at some more homework questions as we go a little further in the assignment. As you get up past like 36, 37, 38, these get a little bit tougher because you have to choose the model. Let's look at 37 and 38. Let me just read these to you. 37 says during working hours, Sue gets 5.8 calls per hour on average. What's the probability she'll get 0 calls next hour? What's the probability she'll get 5? And then in 38, it's kind of a related scenario. It says 9% of her calls, 9% of Sue's calls come from her mother. What's the probability that in the next 10 calls, none will come from her mother or 1 will? Okay, so here's the hard part of it, is saying what's the random variable? She's getting 5.8 calls per hour on average. What's the probability she'll get 0 calls? Okay, the random variable we're interested in is how many calls? How many calls in an hour? And the values could be no calls or 1 call or 2 calls. This is a discrete random variable. And I'm given that there are 5.8 calls per hour on average, and it's a reasonable assumption that the calls are scattered randomly through time. So this is a Poisson situation. There's something scattered in time or scattered in space, in this case phone calls. So the hard part is thinking Poisson model, and then for a Poisson model what I need to know is the mean. The cool thing about Poisson is you just need to know the mean. 5.8 calls per hour is the average. That's the hard part. And then I go to the actual question, what's the probability she'll get 0 calls next hour? Okay, so now on the calculator, my setup is Poisson PDF, Poisson probability distribution, and I want to tell it what probability distribution I'm talking about. So I've got to tell it that the mean is 5.8, and for the Poisson, that's the only information the calculator needs. And then I've got to ask, what's the probability that I'm going to get 0 calls? And that's going to give me the first answer. The other one is, what's the probability she'll get 5? Okay, so just repeat this with 5 in there. The hard part is figuring out the distribution and what the input has to be. The relatively easy part is getting the calculator to tell you. In 38, though, even though we're still talking about Sue and phone calls, it says 9% of her calls come from her mother. What's the probability that in the next 10 calls, none will come from her mother? Okay, now this isn't talking about how much happens in an hour or 2 hours. It's not an interval of time. It's a number of calls. It's in the next 10 calls. So this should raise your antennas about a binomial distribution. 10 trials. And then the next question is, okay, so if there's 10 trials, 10 times the phone rings, is there a fixed probability of success on every one of the trials? I guess success here is it's mom. And it gives us the right information because it says 9% of the calls come from mom. So, the hard part is figuring out that this is binomial. There are 10 trials, because we're talking about the next 10 times the telephone rings, and that's n, and the probability of success is 9%, 0.09 from mom, okay? Percent of calls come from mom. Now it's relatively easy to answer the question, what's the probability that none will come from her mother in the next 10 calls? So now you're going to do binom, PDF, and you got to give it the distribution first, right? For the Poisson, you only need to give it the mean. For the binomial, it's got to know the number of trials and the probability of success. So you put in 10, 0.09, and then you ask it k, NBK. What's the probability that I'm going to get 0? Yeah, and then you're just going to repeat that with 1 in here for the probability that 1 call comes from her mother. Continuing along here, you have a question about 2/5 of the hikers who visit Scott Falls are female. What's the probability of the next 10 hikers, 4 or 5 will be female? It's binomial because of the 10 trials, because of the 10 hikers, of the next 10 hikers. It asks a question about the probability that 4 or 5 will be female. So I guess there's a little bit of probability theory from chapter 4 here. But it's fairly obvious, right? This is an OR probability with 2 disjoint events, right? It can't be 4 women and 5 women at the same time. It's either one or the other or something else. So the probability of 4 or 5 is added together. So you're going to have a couple of calculator procedures, and then you'll just add the results. It also says find the mean and standard deviation of the distribution. So you're going to know that for a binomial distribution, NP gives the mean, and the standard deviation is the square root of n times p times q, which is 1 minus p. Number 40 says, on one afternoon, an average of 6 roadkills per mile are observable on Highway 18 through the Van Duzer Forest Corridor. What's the probability of observing 6 roadkills on a randomly chosen mile? Okay, think about it a little bit. The random variable is how many roadkills you observed. It's a discrete random variable, whole number possibilities. Could it be binomial? It'd be binomial if I had a fixed number of trials and I was counting how many successes. But rather than talking about a fixed number of trials, what this says is within a randomly chosen mile, within a certain duration of space. So this is going to be Poisson. Number 41 talks about Wayne Gretzky's NHL career. And let's see, talks about his average number of goals per game. They throw you a bone here. Use a Poisson model to estimate the number of games in which Gretzky scored exactly 3 goals. So you have to set up the Poisson model, figure out what the mean is, and use your calculator to estimate the probability that he would have scored 3 goals. Now, the calculator is going to give you the probability of scoring 3 goals, right? And this is asking you for the number of games in his career. So you'll have a little more work after you do the calculator procedure. You'll have to use that result plus the total number of games he played in order to estimate that, and you can compare to the actual result. Let's see. I think the very next problem, 43, goes back to the example of a casino roulette table and the probability of winning or losing when you bet on red. But then the 2 parts, one says what's the probability that exactly, let's see, the average of 14 bets per hour. What's the probability that exactly 10 bets will be made in the next hour? And the next one is what's the probability that exactly 5 of the next 10 bets on red will win? One of these is binomial, one of them is Poisson. You have to figure out which one is which. And after that, you'll get into a series of problems that are normal distribution problems that you can solve with mostly with normal CDF or INV norm, similar to the work that you did in Activity 5. Let me point out one that some people find kind of tricky, number 46. It gives you this setup with a normal distribution, n comma -4, 9. Of course, that means it's New Year's Eve low temperatures in Grand Forks, North Dakota follow a normal distribution with a mean of 4 below 0 and a standard deviation of 9 degrees. And then the questions are, find the probability that the low will be below 0 next year, the low will be above 0 next year, and the low will be below 0 in exactly 2 of the next 3 years. The first 2 problems you can do with a normal distribution. Draw the picture and use normal CDF. C, you've got to do a little more than that. And I think you need to bring in a binomial model to do it. So that actually mixes some answers from a normal distribution. I think it uses the answers from parts A or B and what you know about binomial distributions. Fair warning on that. Let me do one more problem and we'll be done with this video. As I continue through the